Hello everyone and welcome to Physics 130. Today, before we start each chapter, I'm going to talk about the learning outcomes for each chapter. Okay? So that's my goal. So chapter 1 is about the concepts of motion, and in short, in this chapter you will learn about the fundamental concepts of motion. Okay? So let's go in more details. By the end of this chapter, you should be able to do the following. First, describe the scope of physics. What is physics and what does it encompass? You should be able to calculate orders of magnitude for a quantity, the order of magnitude for a quantity. You should be able to describe the relationship among models, theories, and laws. What are they? What's a model? What's a theory? And what's a law? Should be able to do that, be able to explain it to someone. We should be able to describe the SI unit system and how it's defined, and then use conversion factors to express the value of a given quantity in different units. So if I give you the volume in cubic meters, you should be able to know how many gallons there are in a cubic meter. Of course, knowing the relationship between a cubic meter and a liter and a gallon and so on. Should be able to go back and forth. All right. We need to be able to find the dimensions of a mathematical quantity, mathematical expression involving physical units. So given a mathematical expression, let's say 1/2 mv squared, knowing that m is the mass and let's say v is the velocity or the speed, we should be able to tell what the dimensions are. Okay? We need to be able to also determine whether an equation is dimensionally consistent. So for example here, if I put, let's say m is mass, and then I say mass is equal to v, where v is the speed, is this equation correct? Maybe the mass is 1 kilogram and the speed is 1 meter per second. So, but is 1 kilogram equal to 1 meter per second? The answer is, of course, no. There are two different units. You need another unit here, maybe we can call it a unit alpha, and that alpha has the right dimensions that when you multiply it by the units or the dimensions of speed, we end up with dimensions of mass. That's possible. Okay. So we need to be able to tell whether an equation is dimensionally consistent. That's very important. Because if an equation is not dimensionally consistent, it means there is at least one mistake, or maybe it's totally incorrect, right? We want to have the ability to estimate the values of physical quantities. So just we give an order of magnitude estimate. How many students are in a classroom? Oh, somewhere around 10, maybe 100. Can't have 1 million students in a classroom or 100,000 in one class or one physical classroom. So we should be able to tell. We need to be able to determine the correct number of significant figures for the result of a computation. In my class, I'm not going to, usually whenever I give you a quantity, it's about 4 significant figures. I'm not going to penalize you for being off by a significant figure or so. I think you have gone through this in chemistry, but nevertheless, we will go over it. We need to be able to know the relationship between the concepts of accuracy, precision, and certainty and discrepancy. So we'll talk more about this in labs also. And that should be it for this chapter.